I want to switch over here and show you guys about how this is going to work in our lab. So if you guys haven't already, go ahead and open up your lab for harmonic motion. There's a link in there to our simulation, so you can go ahead and open that up now. So you can follow along a little bit with how this is going to work. So I'm going to kind of walk you through this experiment. So let me come here. I'm going to share this tab with you. Okay. So what I've done here is, okay, I pulled up the simulation. So when you open it up, that link, you should see this. Okay. So if you have problems seeing this stuff, just let me know. But we have, okay, here for masses and springs, what we're going to do first is we're going to go to the intro section, right? There's a lot of stuff here to play with, but the only ones we're really going to use today are the intro section and the lab section. If you guys want to kind of check conservation of energy, there's some cool stuff here, or the vectors here. There's stuff to play with. But the main one here we're going to use first is intro. And this is what I'm talking about. If I have two springs that are the same thickness, right? So I kind of don't play with this here. I think in the first part of our lab, we're going to go all the way with the thinnest spring. So both settings are going to go all the way to small. And you'll see my spring gets thinner. Here, if I put it all the way, it gets thicker. So here I have a spring. And what I'm going to do is I'm going to hang some mass on there, right? So let's say I hang a 50-gram mass. Hold on. This is... Uh-oh. Give me just a second. Man, it's a little different. They've changed it on me. Okay. Um, so what I have here is I think it's going to be a little bit different, guys. You're going to have to um, click this little stop button here in order to get it to stop oscillating. So initially it's just supposed to stretch and stop, but now it's going to stretch and you're going to have to stop it from oscillating automatically. Sorry, you're going to stop it manually by pressing these little stop buttons here. So let's say I kind of connect one of these. This thing is going to keep stretching and it's going to keep bouncing, but I actually just want it stopped. I want to know where is the equilibrium, right? So use these little stop buttons right here. So sorry about that. They updated it on me. So here, let's say I have a 50-gram mass and my spring will stretch a certain amount. I put a 100-gram mass and my spring should stretch twice as much, right? It's twice as much mass, so it should stretch twice as much. So there's a few things here. On the side, I have a ruler. So you guys are going to use this ruler to measure exactly how much it stretches. So what I can do here is I can kind of zoom in on this. Maybe I can't. Let's see if I can. Okay. So right here, you can see that with our 50-gram mass attached, we've stretched what, about 0.16 meters, so 16 centimeters. So this ruler here is in centimeters, so it's 16 centimeters or 0.16 meters. You're going to need everything here to be in meters. So you're going to do 0.16 meters. And if I did this again for the grand mass, you do the same thing. Just line it up with that top line, and then it goes down to about 33, 34, right? So somewhere around here. And what you can do is you can measure their displacement. Remember that the displacement is downward, so it's negative, right? So negative displacement, just so that you have the right direction, because you should end up with a positive spring constant. So you can use that in the first part of our lab to find the spring constant, okay? And what you're going to do is you're going to go to your lab, and you're going to use that to fill in your information. So let's kind of go to our lab here. All right. So I'll kind of show this with you guys. So here's our lab. Again, same thing for this lab. We have all of our formulas here at the beginning, right? So kind of what I ran through with you guys. So you guys will, so initially it was here as stretch, now it's intro. I'm going to check to see if maybe I have a different link for the original one instead of the updated one, but we'll see. So what you guys will do, again, just like here, you're measuring, and then you go to this table, and for the 50-gram mass, I've already replaced this with 0.05 kilograms, so you have to convert it to kilograms. We have to have everything in our standard units. So here for my 50-gram mass, 100-gram and 250-gram masses, you're going to record their displacements, and then you're going to use that formula that I gave you to find the spring constant. That here is, if you do it by the lab report, it's going to be 5. So I know how much mass I'm putting. My displacement goes here. Remember, my displacement is negative, so my whole number here should be positive. Okay, and then you'll put your spring constant right into your table, each one here, and then you're going to take the average of all 3 of these spring constants. So let's say I get 1.2, right, 1.1, and then 1.3, right? So if you get this, then you'll average them all out, and you put that here. So the average of all those numbers is this 1.2. And once you do this, then you're going to use this number here, this 1.2, for the second part. The second part of this table here is if I know my spring constant, but I don't know how much my mass is, right? So in this case, I will do 1.2, 1.2, 1.2. Now I know what my spring constant is. You'll measure your displacement with each of the unknown masses. So I have a small, medium, and a large mass. They've got them right here, small, medium, large. Let me just check to see. So the colors are a little bit different on the setup that is currently on there. That's okay, the color doesn't matter. So I put the sizes next to them also. So small, medium, and large, you'll get their displacements, and then you'll use that with the other formula that I gave you guys, solving for M, to find your mass here, right? So that will be what you use for the first part of the table. Okay, so for the second part, okay, we're going to be doing something a little bit different. So for the second part here, we are going to, okay, we're actually going to, instead of relying on the equilibrium condition, we're going to look at the motion of this thing. Okay, so we're going to look at the oscillations. So pretty much we're going to let this thing go so that it oscillates upwards and downwards. Okay, and it turns out that if we look at this oscillation, remember we have this idea of period, right? Period being how much time does it take you to complete one oscillation? So this is in seconds, right? So if I have, let's say, the moon going around the Earth here, how long does it take for the moon to go all the way around and come back to its original point, right? And we measure this in seconds. So what you're going to do is you're going to measure that amount of time. If you measure that amount of time, you can find, if you know the mass, you can find the spring constant, or if you know the spring constant, you can find the amount of mass that you've put onto that. So this is actually a little bit more involved and complex than just using the equilibrium forces, right? You can see here this is much easier, and it's actually easier to just let it come to equilibrium, and then you can find your unknown piece, right? So why would we even bother with this? Why would we even look at the period of motion? And it's actually, this is really neat because we don't need to have equilibrium, and sometimes you can't. Sometimes you can't stop the motion of something to put it on a scale and measure it, or hang it from a spring or do it. So imagine here, just really simply, the moon and the Earth, right? So you can't ever just get it to stop and then put the moon on a scale or do something to it, right? The only thing that you can do is you can watch its motion. And that's going to be for most things in the universe. We'll say like 99.9999% of things in the universe, we can't actually reach. We could just watch them. So in order to get more information about them, it's really useful for us to be able to use the motion of those things versus, putting them on some experimental scale in order to find some unknown value, right? So using just the motion, we can do kind of experiments at a distance and do spring constant or mass the same way without actually touching this system. And so the way this is going to work in your lab, okay, if I go back to the lab that we have here, so open up this tab again for masses and springs. Okay, so on our lab, in our simulation, if you go to the lab kind of tab here at the bottom, you are going to use this mass, and you can kind of hang it here, and it's going to bounce up and down, right? So this mass you can control by the slider here. So if you want it to be a 50-gram mass, or you want it to be a 100-gram mass, whatever, you can actually control that here. There are a few things that would be really useful here. So what I'm going to do, I'm going to put no dampening so it doesn't stop. Okay, so I have this thing oscillating. The first thing I'm going to do is I'm going to put in slow motion because that's going to make it way easier to time what's going on here. The other things you're going to do are put a line for your equilibrium so you can actually more easily see this thing moving. And there's one more line here that we can use, which is period trace. So when I click this button, you'll see this little line come up where the mass goes down, it goes up, and then it comes back down, and then that's it, right? So once it completes that entire trace of a line, then you've completed one oscillation. So you're pretty much timing when this line starts to when it ends. So the way we do that is there's a little timer here in our toolbox. We'll kind of pull this out, and you'll wait until that line is going to start up. So I'm going to wait until that mass comes back through the center. I'll start the timer. Okay, and then it goes back down, and then when it comes back up and completes the trace, I'll stop the timer. So here it was almost 1 second, right? So it's slow motion, so I have 0.99 seconds here. So this is going to be, I'm going to count this as 0.99 or 1 second. And this doesn't actually change with amplitude. So if I did this and then just pulled it further, this would actually be the same, right? So let me kind of wait for this thing to reset. Okay, so once it comes back to the middle, I'll start the timer again. It comes back up. And then once it goes back down, stop it, right? So again, out with 1 second. So it doesn't actually change with your amplitude. It only changes with either your spring constant or the amount of mass you put on there. So how much you stretch the spring does not matter. This is important for your quiz. And so you're going to use this same kind of information again, and the two formulas that you have for using period are going to be used with the same method to find spring constant and mass for your second table. So that second table is going to be the same thing. So I think you may only have two masses here, maybe a medium and a large. That's completely fine. Do what you can, right? So this, we might not have it. So just kind of get rid of it. We'll have maybe a medium and a large mass. And all you'll do here is you'll find your spring constant in this table 2, same way we did in the first table. Put the average value here. Use that average value in these two, and then with your period, you can find the amount of mass. After that, we just have a few analysis questions, and then you're done.